Hello, boys and girls. So this video has several purposes, several ideas. For one, I want to show, people like my brother who do not do any math or coding, how some vibe coding looks like. We're going to do some storytelling and some data generation and doing some statistics. I'm going to explain some math. The math will not be trivial, but I hope it's nonetheless like sort of fun to watch this evolve. And in this video, I will do pure vibe coding, meaning I will code without even looking at the code. Actually, I only downloaded this language, R, the statistics language, 2 months ago. I do not really speak the language, but that doesn't matter because we have this agentic AIs, we can just talk to them. And that's what I will do. I had this idea just under the shower thought that I can also try out to what extent this works as a format, right? So, because it will be like storytelling, it will be like explaining math, and I myself don't really know how this will play out, how this will look like. I don't think this has been done, like explanatory videos with combined with the machine in this way. I expect we will write, 500,000 lines, but not look at it. And it will take over an hour till I'm through with it, for sure. I hope it's not too slow. I mean, be warned, it will be like we will wait for the agent a little bit, and I will have to look what comes out and readjust and all these kind of things. So it will be sort of a vibe coding session, really. But you will learn something for sure. So I'm sitting here with my IDE. I have this empty file called vibecode.qmd. MD, this is like a version of Markdown, and we are going to be able to generate PDFs with it. I can render it on the left side. You do not have to look at the left side. This is just where I generate the output of the script. And I can also open it here, but at the moment it cannot open it because it's empty. There's nothing. I have an OpenAI subscription for like 23 euros, and it has this agent codex. I'm using codex 5.1 max, and there I see this chat window. And I wrote ping, I wrote pong, and I will be writing some text here. What I wanted to do, I will explain it to you, and we will just see what happens, right? So I can roughly tell you the setup that we are going to do. So I have here like 10 lines. You will not be able to read it here. I think it's so dark. 10 bullet points, how I outline the narrative here. So it is about a bunch of students, let's say 30 students, and they are learning for their German exam, and they have a midterm, and they all learn at different amounts per week. So they learn roughly like 20 hours per week. And then they will have a midterm and get a grade. And the more they learn, the better the grade is. And the more they learn, the more stressed they are. But the better the grade is that they get, the less stressed they are. And so there will be like 3 equations, these simple linear equations, which I will use to generate data. And once we have the data, we will do statistical analysis on it. And I will explain some of the math to you. If you do not have any math background, the math itself, like the formulas, will not help you much. If you know a little bit of linear algebra, then you will learn something from this. But in any case, it's not really about like necessarily, getting to know the math in particular. You will also see some nice plots. And with that said, I will jump into it. So I will, you will hear me typing. I will type what I want from the thing, and then I will talk a little bit about it with you, okay? So, I can actually make this a little bit bigger. Yes. Okay, so my first message here is we're going to write a narrative PDF and do some stochastics explainers. First, we generate a few data points, come up with 20 student names, and for each of them, sample from a normal T centered, typo, at 20 with an STT of 10. So I say, I want 20 numbers for each student, one number. They roughly learn like 20 hours per week for this test. With some stochastic variation, this will be like a random sample, roughly speaking, plus minus 10. And then the PDF should make columns. So we will not look much at the output here. You see it generated this content, and I can already render it. I realize now that, since we want to reuse the numbers and look at the plots repeatedly, it will be good if I tell it to remind all the values that it will. Now it's sampled random values, right? And next time I re-render the PDF, it will generate new values. We don't want that, but okay. So as you can see here, it came up with 20 names. Eva Patel, Emma Russo, Mason Lee, Lucas Meyer, and here the number of hours they learn per week. So you see Emma learns, in this case, 37 per week. And that's the table. Here Grace Turner even only learns 1.15 per week. That's not good, Grace. So okay, I will now tell it to actually sample these values one and then reuse it. And actually, let's do even more. Come up with 10 more names. Sample also for them. In fact, resample the values and save them to hard-coded 30 values because we will use them later. Okay, and actually I will, let's do it. Let's do it stepwise. It helps a little bit if you don't do like a million tasks at once, because then the chance is higher that you firstly oversee something going wrong and that it will actually do something wrong in the first place. So I told it now to actually make 30 values and write them, take these 30 fixed values. So it will actually like come up with fixed numbers that will show up in the script themselves, is what I expect. Yeah, so this is this. Looks good. Okay, now we're going to sample 30 more values from a random variable G. So the G is going to be the grades that they get on the midterm, okay? For each student, one value. G is defined as free T plus standard Gaussian noise of with STD. 20, let's say. I will actually say the grade that they get is, and the grade on the midterm is, they all get like 25 plus, and then 3 times as many points as hours they learned, right? So they will get like, if they learned like 20 hours, they will have like almost 100 points. And then I add noise even on top of this, so the grade will also be a noisy variable. Also save these 30 values for later, and also show them as second row in the table. Okay. So we see here the t values, and I expect now another vector, another list of g values will pop up. Why these t values? Okay, it explains even what it does. That's cute. Sample table. You see here it's thinking and working, generating data in the background, and then it will add this as lines to this code as well. David Foster, Matteo. But are these like typical American names? Okay, so let's see. Yeah, here's the G noise. Okay. It's interesting that it calls it T values here and G noise here. It's kind of okay. Okay, and the G values are 25 plus 3 times T values plus noise. I don't know if I like that coding style too much, but okay. No, what I mean is that why didn't it write T noise before as well? Why is this like this asymmetry? But okay. Okay, now it called it normal sampling demo. Okay, see here the table. The student Ava learned for 7.5 hours, and she got a G value of 58. We can of course see that, you know, the people who learn longer, like Noah learned for 40 hours and gets a score of 163. It's good that there are no negative values, like accidental negative values. Otherwise, I would have had to tinker a little bit with the values to get like, you know, interpretive values. Okay, so I will tell it, you know, T represents the hours they learned for the final upcoming test, and G represents the grade they got on the midterm. The grade is better if they learned more. And now the final equation, the stress. Okay, so we are going to introduce yet another random variable, S, which is given by, and here's my magic numbers, 30, and you know, magic numbers, they are just so that I think something sensible comes out. I've written down this in these bullet points. So S is, let's say 30, the stress level, right? Let's say it's like 30 times 2t minus 0.3 g plus another standard noise of, let's say, in this case, doesn't really matter, 17. std. So add a third column. Well, I mean, sample those values, save them for later too, and add a third column showing them. Patch. Okay, so the idea is that they have a certain stress level. Usually the base level would be like 30 out of, I don't know, 100. And if they learn, they get more stressed. I mean, this is my stupid model. I think I said twice the amount of hours they learn, that's the stress that's added. But if they got, they get a grade, and the better the grade, maybe the lowers the stress again. So we have this additive equation. The stress is like 30 plus more if they learn more, but less if they got a good grade. And the nice thing here is that it's not like it's not 100% intuitive what the stress level is, because the grade goes up with them learning, the stress goes up with them learning as well, but the better grade that they obtain from learning more also lowers the stress again. So there's like two effects. It's a randomness on top of randomness and a bunch of dependencies, which I came up with so that the data is not just linear plots, and it looks like something. And we can investigate. I can find it out with you as well. So, okay, so now I see right at the start, it explains a little bit about our random variables. And here it has this table with the 30 students. I see Mia has negative stress level, so I will actually go in and fix that manually. Okay. The problem is, okay. So I will cheat here and say the baseline of this levels not at 30 but at 31, which will have the result that all the stress levels are positive, just so that we can have some more intuitive plots. Okay, and now we can start doing plots. So create, what do we want to see? Yeah, we can actually create like they're called like ggplot here, plot, and or scatter 3D, I don't even know the function name, that shows the stress level as for all students over to access the time and grades. Also add a 2D plot showing grades over time. Okay. So as you can imagine, now we're going to get a scatter plot. We're going to get points that give us a first impression of the data. Now, our data is fixed. I'm not going to touch the data anymore. The rest of the video, we're going to do the math of actually like taking this data as given. Like, let's say we have like some queries or investigations or medical examinations of these students, and we have their grades. And we're going to reverse engineer by just ordinary least squares the dependencies. There should be like 30 and 3 times and 0.3 times, these sort of properties, and we're going to see some nice plots. And more so than this narrative, I will explain to you like the cost function for this sort of. What does it do? It looks like it reverted my change. That's crazy. You see here it says it changed from 31 to 30. So it resists my hack. That's interesting. Okay. I will actually tell it, change the computation of the S values from this here to 35. Okay, so now it will do the change itself. I did not expect that it would revert this. Actually, does it say why it did this? I guess because it documents itself of using 30, and then the value is not, also update your narrative with this new equation. Because then it has conflicting information, right? At the beginning of the PDF, it says 30, but then in the code, it says 35. So I think that's why it decided to fix one of them, which makes sense. So now I've cheated by looking actually at the code. I wanted to have the pure wipe coding, but from now on, I will actually close this. So I guess now we have below this here is plotting functions, various of them. I will now, for the rest of the video, just close this completely off. I will not look at the code again. Okay. Oof. It says Plotly missing. So I have a library not installed. I have please use some other plotting library that I have installed already. I could also tell it to install the Plotly library, but it's easier that way to just refactor it, because I think that's a shorter time to hold myself up with this. I mean, I hope there's because I have actually never used 3D scatter plots in R, because I've only downloaded it 2 months ago, which is why it doesn't have the library to do this. But yeah. So you see now it replaces some library code. This is, this is not the code file. This is it reporting what it does. Okay. That worked. Okay, so here with the column, it looks good. All values are positive. And Mia has a stress level of 4, so she's super chill. Whereas, who has the highest here? Is Emma has 80 stress level higher than her. Despite having such a good test, Mia has a horrible midterm value. But she learns more, and I think this is more like an outlier, because not really. I think she's also among the people who learned the most, which stressed her out. So here is the midterm grade G over the study hours. It looks nice. It's a linear plot with some noise. We see there's some people who didn't study much. Let me actually see. Who is this? Well, actually, we can tell it. We can now tell it to. Oh, and this is 30 people who. Oh, this is really a cool plot with the box. This is 3D, so the more they study, the higher the midterm. But yeah, the stress level still goes up. I mean, I guess my +2T is much more impactful than the lower ring of stress due to good grades. I mean, here I don't have access, but still. Okay, so I would tell it in the 2D plot, can you add small labels to all the scatter points that should I be annoying to the thing that tell us the first names of the people. And I will also also add 2 more 2D plots. The stress over time alone and the stress over the grades, and then do some, like, we're going to do some regression, and we're going to make the full model and reconstruct the full model parameters. But now, just for visualization sake, and I will also tell it to already do like partial regressions and add them to all the free 2D plots. And do for all yeah, with a pink line, just for the giggles. So, I will now write the names here. I hope it's not going to be too busy. And also I will do like regression line. But this regression line will only take into account these 2 variable values. So there's not like this dependency is not like taken into account as nicely as what we're going to end up with later. Okay. It's a little bit more dangerous to tell it to do like 3 different things, but it should handle. Okay, so we see Lily is an outlier, and Ethan is not an outlier. And I could do some theory now. I could talk about outliers and leverage, but okay, I will not go that far. Yeah, we already saw Mia. She's the one who learned the least, and her grade is also not great. But for example, she has a better grade than Sebastian, who learned like almost 10 hours. So pure or stupid Sebastian. So let's look at Lily. Here this is just a randomly sampled value. The grade is just an outlier with the noise. It's quite far off. Let's look at Lily. Here, Lily Gardner studied 28 hours, but has a grade of 174. Has she actually the best grade? No, Ethan is better. And the stress level is, moderate at 50. And who did I say? Ethan? Ethan is best? Yeah. Yeah, Ethan has a grade of 191, despite not learning nearly as much. No, despite learning. Okay, now he learned the most and he got the best grade. So I guess learning pays off after all. Okay, and I didn't tell it explicitly, but it also added the names to all the other plots apparently. Here is the study hours and projected. It called it projected. What? Projected final grade S? What? S is stress, right? Didn't I tell it? So you see here. Here's the now is the question: was I not explicit enough? Because it says projected final grade. I definitely did not talk about projected grades, but I think I didn't make it explicitly that what S is. S represents the stress level. I talked to you, explained it to you, but I did never mention stress level. I think in this. In my conversation with the bot here. Yeah, I just said yet another random variable S. I did not say what it is. It's funny. And it assumes that it's the projected grade, which makes sense, except that the midterm grade has a negative impact on the projected grade does not really make sense. As represented stress level, rewrite the narrative of the text and annotations in this, taking this into account. So what can we see actually here? So this the stress level goes up with study hours final, but it's, I mean, my standard deviation is quite high. What did I choose? Or was it like 15 or something, right? Or even more. So this is quite a messy plot, which I like a lot. That it's not, you know, it's just some strict line. And I think we have another plot. Yeah, this is another plot. We see the strong, like the long learners, Ethan and so on, Ethan and Nia, we will talk more about these two people. They also show up in this plot here. So yeah, this is already interesting, right? So because stress level also in this regression goes up with the midterm grade, despite, let's look at the equation. Yeah, the model, yeah, this is nice. So the model says the stress should go up with times learned and down with the better grade. But because the time learned and the grade is also correlated or dependent, it turns out that in this partial plot, also the stress goes up with the midterm grade, right? Because the midterm grade also predicts how much they learned, and if they learn more, then they are more stressed. So it's you know, you have these statistical effects that are not completely obvious from the intuition, but like how things average out and how independent this comes out. This is exactly what's nice about these kind of things. Okay, so the last thing I told it was to talk about stress level. Now I want to have the PDF. Can I tell it to plot this thing from another angle? That's the question. Because, you know, I don't like it too much because you don't really see the visuals. I will ask it, can you plot another 3D scatter plot where you show the same data from a different angle and put that plot into the same figure? Oh wow, that's now changed. Because I told it to add this to the narrative. We have a broader table now. Wow, it actually did it. Now this is a little bit of a random angle. I'm not sure if this is super helpful. I mean, I told it to a different angle, right? I would have liked if it just, you know, rotated this in the GT plane. Okay, the second plot should be a rotation by 100 degrees, and this rotation just happens in the TG plane. right? Because I mean the problem with this plot is that it like tilted it around. It makes sense because we consider the stress as the return value, that it's still an upgoing axis. I enjoy this format, but the problem is, of course, it's so slow, and I'm waiting myself that it's probably not going to be so interesting for other people. Okay, so this is not what I wanted. It also, I mean, it looks still cool, but it didn't have has the S axis to the bot. But okay, doesn't matter. I don't want to hold myself up with this one. I will say, remove the second plot. And now, we're going to define the design matrix, the statistical design matrix. Okay, I'll consider, okay, and now we're going to do some statistics, OLS explaining. First, define the design matrix X with calls T and G, but also once in the first. So to do the regression in this, at least 30 data set, but it's like multivariate regression, so we have like these two variables. We're going to define now formally what our data is, which is X, capital X, which holds the times and the grades, and the return, which is S, the stress. I wonder if I should rename it. Yeah, I will go with standard names, and I will call just the data matrix X, and I will rename the values of S, Y, just so that we get the standard notation in. Because now, in the rest of the video, I'm going to explain a little bit of a math, and we're going to do the regression that it is capable of doing on its own in the background. But we're going to like do the math like proper and explain it also in the text. So, okay. It has a lattice error, so it does not know how to compile certain formulas it wants to draw. First I tell it, call the 30 data values sampled from the random variable S by the name Y, just to change the standard notation. Also, I got this compilation error. Fix it. So I don't know what the problem is here. Sometimes I know that this R program has problem with LaTeX if there's like blanks right after the dollar bracket. So if you know LaTeX, you might have an idea what I'm talking about, but yeah, it doesn't really matter. I'm confident that they will manage to refactor this. Okay, so we call the S values Y values now. I'm actually not sure if I like that, but I guess I told it. Jesus Christ. I see. It didn't even use dollars. Or it decided now to not use dollars, but instead a different kind of bracketing. I hope we don't run into problems with that. I don't really want to hold myself up with just rendering. Stress samples. Jesus Christ. I will actually see how many lines we already got. Oh, under 300. It's not too bad. Okay, it was more annoying than I hoped. Let's hope this checks out. Oh, god damn it. Yeah, so this I could probably, well, let me see. So it doesn't manage to render the LaTeX, which is super annoying. Okay. So here it uses it prints the text with this cut command into the PDF. But I will just tell it to refactor and avoid this altogether. It's not necessary because it can literally just type outside of the chunks. Okay, so I will tell it avoid all cat calls, pun intended, and just use single dollar signs and write LaTeX exclusively outside the chunks. It was so I say solution. Also I still got the error. Solution attempt, and then I'm thinking for it. I hope this would not happen. that it doesn't should be able to notice error. But so the thing is that there's this code chunks where we switch between text, normal text, and code where it plots and this kind of stuff and samples data and these kind of things. And it previously now wrote the text with the formulas in the same boxes where it did the code, right? This markdown style thing is like the hybrid. Jesus Christ. It's like a hybrid thing where it does both. And now I told it, to completely separate the code from the LaTeX. But sadly, it still didn't manage to do this. What is this? This is absolutely gross. What is the problem? So of course this is like a huge, huge matrix. But nevertheless, why is this a problem? Okay, I get this. Use single dollar signs, not. Okay, now I'm cheating a little. What it tries to do is it tries to mix the LaTeX, the nice rendering from my PDF, with the values that it has computed, these rows. And I ask it now to simplify it and just use the values that it computes anyway, because we keep on using the same values, right? We're not resampling. And so I tell it, don't try, be smart and mix things. Just take the values that you already have, that you know, and put them in the LaTeX box. And sadly, LaTeX is kind of horrible. There's like a million ways to do things, the same thing. And then you have the, oh God. And then you have these Java wrappers and all these kind of things. So, yeah, it did not take hard-coded values, but it again tried to mix things. Here, these brackets mean we are in a chunk. But I don't know are much, but I know as much that these are the code chunks where it tries to like use the data that it has, the data with the LaTeX. So it tries to marry two worlds here, and I'm not convinced if that will work. If it will not work now out of the box, I will just tell it to just write a table and do not write a fancy LaTeX. No, but this actually worked. So let's see how that looks. So this is the table from the start, right? This is really the data. I want to have these values, the t and the g, as data in X, and y is y, as the return value. The names are irrelevant for the regression. And okay, it actually did. So this is the proper design matrix, which I told you is long. It has the values t and g here. It managed to create this with this code where it takes the actual code and marries it with the LaTeX, and it has this nice rendering thing. Shouldn't have asked it in the first place. And I will not explain these ones. These ones are because we explicitly want to work not just linearly, but a fine linear. Like we want to have an offset from 0. We do not want, our model does not say that stress is 0 at 0 learning time, but we have this offset, right? I started with 35, and now it should also be able to model this, and that's why there's this hard-coded ones. Okay, and also has this y. Okay, this is ugly, but I guess it's exactly what I told it to do. So this is the y, the stress levels, right? Are the stress levels all under 100? That's interesting. Let me just double check this. Yeah, I guess so. Who's the most stressed person, actually? Yeah, Ethan. It was Ethan. Ethan, who learns a lot, but is also stressed a lot. No, that's not. Oh, on the plot I didn't see stress. I saw the G value. No, so this is not the stress. This is the grade. The stress. This is the stress. Emma and Elijah are most stressed, but they are basically. Yeah, this is basically outliers. Let me see if they're Emma and Elijah. Where are Emma and Elijah? Now we're doing statistics, right? We're looking at data. We're trying to understand outliers. Where do Emma and Elijah lie here? Emma has learned a lot. Where's Elijah here? Interesting. Yeah, Elijah was just unlucky in getting not a good midterm grade. And so that led to him not have such a being more stressed because his midterm grade was already not so good. So this is really fun, right? I'm making my own data set, and you can understand it, the semantics of it. Okay, so now what we are going to do is we are going to now. I'm not going to look at the code again. I hope I don't have to again. Now we're going to make our mathematical model. Let's say the data is given. We have no idea. I mean, by design, all the lines are fairly linear. So this is a simple data set, right, by construction. But we're going to reconstruct it. We're making this linear ansatz. We say, can we predict the stress level from both having knowing how much people learned and how they fared on their midterms. And so the model that we do is we want to predict the stress as this X matrix with the data that we have times some numbers, basically just 3 numbers that define a plane, or in 2 dimensions a linear line. We do the regression ourselves, and these numbers, they should reflect the numbers that we put in, right? They will, like the slope for the time in relation to stress will be like roughly 3 and so on. And okay, so X times beta is going to be the model. Like we're going to get these few numbers that we can multiply with any incoming data point. Like if you give me another student who says, oh, I learned 25 hours and my midterm result was, I don't know, 30. With this model I can predict his stress, and it hopefully is not too far off. It's just a linear model, but since the data is by design linear, it will be quite good in estimation. So I say define the residual R that is the difference between the actual stress level that we also measure for these 30 people, and I'm running out of battery. Fuck. And our prediction. Write down in LaTeX the OLS costs and explain this sum of norms squared. Okay. Then we want to make this error small. That's like the restriction, and I will derive with you the way to compute the best beta. This is called the stationary beta. Compute the stationary beta. Explain the derivative with matrix calculus and end up with the formula for beta. Okay, so I basically just tell it now to do the standard math textbook stuff. We will take our data, but now first we do the abstract math. I will say a little bit about it. Since I'm running out of battery, I will not take it too far. But this is actually what I wanted to get at, right? We generate data and we have something real, and now we can explain the math. Okay, that was fast. But I guess it's standard. Right, so our X is our data, right? It's the time that people studied and the grades they got. And the Y was their measured stress for this data set of 30 people. Okay, this is not nice. I was hoping for nicer LaTeX. Why is this so ugly? Because this is just... It's extremely ugly. That's crazy. Why is this? Let me actually see. I just tell it straight out. What I got now is not nice. Use single dollar signs. I told you. I think I told it before to use single dollar signs for this. So I don't know. Here it explains the math, but this is not appropriate for this YouTube channel. Maybe, I don't know. Need some Python. Some LaTeX packages to make nicer formulas, check if I have them, and if so, include them in the script. So I now let it, in case it needs more, include more stuff. That's crazy. Why is this so ugly? So I don't know why. I have seen this before working much better. Now what is this? It doesn't even write down the beta. What is your problem, bro? So yeah, I don't know why this is, but firstly it didn't edit these brackets. Okay, I expect this will look nicer now. But I guess codex 5.1. So I compiled now while it was still working. It's also not a good idea. Okay. Okay, this is also stupid here. Yeah, so, okay. So this is not R, but since I wrote a lot of LaTeX in my life, I know that what it tries to do here is not a good idea. With the star, so we have the beta, and the stationary resolution is beta star, and it should use the asterisk symbol, not backslash. Okay, I think I'm lacking some IceMath packages yet. I should install those, but I will not do this in this video. Yeah, okay, so we got nicer formulas here. I have to install some packages. It seems to make this nicer. We have 7% battery left. So we have this residual now. I hope you can read this. Let me see. Yeah. The difference between the measured values and our predicted values x beta. X times beta takes all the data we have, the coefficients we want to compute. We want to minimize this error between a measurement and this prediction. So this is equivalent to minimizing r squared. This is some matrix expression. The stationary point where it's minimal, right? Your calculus, you take the first derivative, you set it to 0. Convex optimization, the subgradient must contain 0. And you get this equation here that needs to be 0. And this is like a matrix equation. You invert, if you can, this matrix x cross x. So you take this fat matrix, you transpose it, you have like a long matrix, and you have a tall matrix. You multiply them together, you get something small. And it should be invertible, which randomly it will be here because we have so much data. And then just solving this simple equation gives our beta. So I will tell it, compute x transpose x manually and show me the matrix in LaTeX compute the determinant, just to see how far it is away from being not invertible. And tell me the beta coefficient. Write some text that explains beta with respect to our student narrative. We have the regression now, and finally we are going to include this in this 3D plot and make some adjusted residual plot as well. So okay. So while it does the final plots, let's see what it got for me. Okay, so this is this x times x matrix, right? This must be invertible. The determinant is some huge number. Like it's a bunch of hundreds, scores and so on multiplied together. So this is all fine, as to be expected. And here I have my coefficients from my like model, right? So I did not collapse the model anyway. I know there's a big correlation between the grade and this time learned, but I still take all of the random variables into account. And I get back these numbers. They are very sharp, right? I used 2, like I used 35 plus 2t minus 0.3 g. And apart from the intercept, which is not fantastic, these numbers are super sharp, which is probably because the standard deviations even along the t-axis are fairly large, so it has data on all sides quite well, but the intercept is maybe the slope was even too big, so I don't know what the strongest interpretation is why the intercept is seemingly more off than the slopes, but overall this is very nice. Very good predictor, right? The numbers are so good that I can predict the stress level apart from the offset, the systematic offset, quite well. And here in the final seconds, I get another compilation error. I run into simplify if you have to, because I'm almost out of battery here. I have 5%, that's okay. What? This was one character changed? I'm not sure if I should believe that. These fatal errors are still my math packages, my LaTeX packages, which don't seem to be a big issue here. Okay, so here Yeah, sadly I cannot rotate this here in this application, but it looks like it fits more or less. And it added I actually wanted to make it the 3D plot again and add the regression in. It actually now added my regression line in the 3D plot in the middle of the text, which is not what I wanted, but okay. Maybe it's on me. That's interesting. So we know that my regression is good, but I might have messed up with. Maybe not. Maybe let's just cancel it. So I these are like this. They should be the adjusted plots, but why are they both so flat? Okay, so I plugged my laptop in and was like, hey, I can just ask why are the lines flat, and it pointed out that I said adjusted residuals for y, but I wanted an edit variable plot, and I think I wrote that, but I think because of how I described it, it did not condition the y for the g. It just conditioned the x-axis for the g, but not the y-axis to the g. If you do both, then you get what I want, which looks like this. So here are these proper edit variable plots that show the slopes that we got. So 2 for the time. The more you learn, the higher your stress is, as per my assumption in the model. While the better your grade or at the midterm, the less your stress is. So that's what I wanted to see. And with that, I leave you for the day.